13-6 is on circular functions, so we're going to start with the definition of a unit circle. A unit circle is a circle with a radius of 1. A circle with a radius of 1 unit centered at the origin on the coordinate plane. So again, a unit circle is a circle with a radius of 1 unit centered at the origin on the coordinate plane. In the last lesson, I mentioned how sine goes with y, cosine goes with x. So this is a way for you to actually see that. So the point would be xy. So cosine theta, sine theta, cosine representing the x, sine representing the y. And this is used for all circular functions. So for our first example, the terminal side of angle theta in standard position intersects a unit circle at p 3/5, -4/5. Find cosine theta and sine theta. Cosine is x, so cosine theta equals 3/5. Sine theta is y, so sine theta equals -4/5. And that's your answer, cosine theta and sine theta. A periodic function has y values that repeat at regular intervals. One complete pattern is a cycle, and the horizontal length of the cycle is a period. Right here I have the graph of sine 45. So let's use this point. It goes up, the crest, the trough, and then back to the center. That will be a full cycle. And then the length of the cycle is the period, which for this one is 360, 0 to 360. And you have to go up and down to get back to the original. That would be a full cycle. Don't just go up or just go down. This is the full unit circle that I was mentioning we hadn't really seen yet. See how they have the x's and the y's? This is on page 850 in your book. Find the exact value is example 2. One thing I'm going to do first is this is not in the 0 to 360 or 0 to 2 pi figment in radians. So I'm going to take 2 pi minus 3 pi over 4. Or I guess really I'm just adding 2 pi to this is what I mean to say. So 2 plus -3/4, and that's 5/4. So this would be 5 pi over 4. So I'm finding cosine of 5 pi over 4 if I'm using the unit circle. Again, I just added 2 pi, kind of like if I wanted to add 360 or something to get back to the original. So if I'm looking at that chart I just showed you in your book, 5 pi over 4, the ordered pair, I'm looking for cosine, so I want the x, which is -2 over 2. And again, look at that unit circle, that's how I'm getting that exact value. If you want to test it again, cosine, well I guess 5 pi over 4, let me look, is 225. So cosine 225, if we did -2 divided by 2, it should be the same, which it is. So you can always still check it with your calculator. B is sine of 420. I'm going to subtract 360 to get back to the original. It should be 60, I think. 420 minus 360 is 60. So I'm going to look at my unit circle, sine of 60. So I find 60 degrees, and then I find the y coordinate, which is radical 3 over 2. Again, if you wanted, this one you just type in sine 420, and then type in radical 3 divided by 2. It should match, which it does. 13-7 is on graphing trig functions, so I'm just going to kind of read through this real quick with you. The amplitude of the graph of a sine or cosine function equals half the difference between the max and the min. So remember, difference is subtracting and then half of that. And I have a chart here. This chart will be helpful to look at. It just kind of gives you what it looks like, where it starts, like sine starts at 0, where cosine starts at 1, how the graph kind of looks, domain, all real numbers, where the range falls, the amplitude, which is telling you how high up or down it goes from the axis, and then the period's 360. So every 360 degrees it starts over. So like if you went from middle to middle or top to top or bottom to bottom. And then this right here is going to be the most helpful because it's some formulas you could use. Y equals A sine B theta, or Y equals A cosine B theta. Amplitude is just the absolute value of A, and the period is 360 divided by the absolute value of B. So this is just so you know like what you're looking at right here in this example. For A, we're finding amplitude and period, we're finding these, so we need A and B. let's see, cosine. So A is 1, because there's no number there. B is 1/2. So for amplitude is absolute value of A. So amplitude equals the absolute value of 1, which is 1. And then period equals 360 over absolute value of B. So 360 divided by 1/2, or 360 divided by 0.5, which is 720. So the amplitude is 1, and the period is 720 degrees. For B, y equals 3 sine 5 theta. So A is 3, B is 5. For amplitude, absolute value of A, so that's 3. Amplitude is 3. For the period, 360 divided by absolute value of B, so 360 divided by 5, which is 72. So the period is 72 degrees. Amplitude 3, period 72. This little chart just tells you where the theta touches the x-axis. So if it's A sine B of theta, it touches at 0, 0, half of the period, and then at the period. Where for cosine, it touches at 1/4 of the period and 3/4 of the period. So that's because cosine doesn't start at the middle at 0, like sine does. It touches 1, 2, 3, and that would be the full period. Cosine, this is the top to top. So it just touches 1, 2, which is 1/4 of the way and 3/4 of the way. We're going to find the amplitude, period, and the intercepts to be able to graph. So A is 3, and B is 1, right? Because it's just a 1 there. So amplitude equals absolute value of A, which is 3, period, equals 360 divided by the absolute value of 1, which is 360. And then for intercept, since it's cosine was at 1/4 of the way and 3/4 of the way of the period. So 1/4 of 360, which is at 90. So intercepts are at 90, 0, and 3/4 of the way, 270. So that's the 2 times it's going to touch. So to graph it, the amplitude is 3, so 1, 2, 3 is where it starts. Remember, cosine starts at the amplitude. And then 1, 2, 3. I should mark that as a 3. And then we have 90, 180, 270, 360. So by the time it gets to 360, it should be back at the top. And then we know it's crossing the the x-axis at 90 and at 270. And then if 3 was the amplitude, it will hit down here at -3 in the middle. And then this would be a full period. That's how you graph it by hand. Now I'm going to keep going. So this would be 450. I'm not worried about exactly writing all the numbers down. But this would be 1, 2, 3, 4. So this is the next time it would be back at the top. 1/4 of the way it would touch, and 3/4 of the way, and it would be at the bottom in the middle. So there you go. That is the graph for y equals 3 cosine theta. Okay, A is 1/2, B is 2. So amplitude is 1/2. Period is 360 divided by 2, which is 180. It's sine. So our intercepts, we have 0, 0. And then it's half of the way, so 90. And then at the end of the period, 180, the full thing. So those are our 3 intercepts. So we're going to get our graph set up. And let's call this 1 and -1. So we start at 0, 0, and then we have 90, 180, 90, 180, 90, 180. And I'm just going to mark those 2 to start. So by 180, we're back, and at 90, we're here. At the amplitude is 1/2. So that'd be in between, it would go up, and then -1/2 for the bottom. And this would be what it would look like. So then you can keep going. So it would go up to 1/2 to the middle, down to -1/2 to the middle. up to 1/2, middle, down -1/2, middle, and then you just connect it. And that is the graph of y equals 1/2 sine 2 theta. Frequency is the number of cycles in a given unit of time. The number of cycles in a given unit of time. And next, this is the tangent chart. So tangent's a little bit harder than sine and cosine. If you notice, it'll just go up and then you'll have this dashed line and it will do it again. So it's the same shape over and over, but they have these dashed lines. Basically, that's where the amplitude is undefined. It just reaches towards infinity. So that's what tangent's graph looks like. The period's only 180. So it's just going from here to here, that's 180. Intercepts are at 0, half, and the full, so that's like sine is. And then basically just knowing how to find like those dashed lines would be halfway between. If you look at the formulas here, period is 180 over b instead of 360. There's not an amplitude, and then the asymptotes are the odd multiples of 180 over 2 times the absolute value of b. Example 3, find the period. So this is 1/2, that's your A. B equals 1. So we actually don't really need that 1/2 because that's not what we're focused on here, right? We don't have an amplitude, we're using the B. So our period would be 180 over 1, which is 180. No amplitude, and then the asymptotes, okay, so 180 over 2 is 90, and it's the odd multiples of that. So it'll be the, let's just say some asymptotes. We would have one at 90, we would skip 180. We would have one at 270, skip 360, because on those other ones, it's actually touching. So it dash line touches, that's why it's the odd. So 270, skip, what's the next one? 360, and then 450, and you can keep going, but it's every other one. So to graph this, sorry, that's not a very good line. This will be at 0, and then we have an asymptote at 90, and then we touch at 180, asymptote at 270, we touch at 360, and then we'll do one more asymptote at 450. And you could keep going. Obviously, I didn't keep going. And then I should go back here to -90 and show you that. And then all you do is you just curve, kind of like a little squiggle. Just start at the left side, touch in the middle, go to the right side. Start at the left, touch in the middle, go to the right. And you could keep going if you wanted. So that is tangent. Cosecant, secant, and cotangent are just the opposites. So like cosecant is the opposite of sine. So the sine graph would fit in between here. Secant is opposite of cosine. So the cosine graph would fit in between here. Cotan is opposite of tan. So you'll notice instead of going up, it goes down. So that's the idea with these three. And you use the same, like the charts like before. They do all have asymptotes this time though, because that is different about them. Find the period of y equals cosecant 2 theta. A would be 1, B would be 2. So for the period, we use the 360, right? So you do 360 divided by 2, which is 180, and then graphing it. So we start by getting it set up. We do have an amplitude this time, so that's at 1. We know that it does not start at 0. So we come over like this, and it would start here, and then it would go up. And then at this one, we would have our dashed line. And then it skips over at our next one, and it would go down. And then we go over one, and dashed line. And that would be the full cycle that you kind of see there. So we come over, and then we'd go up to our amplitude. And then we'd have our asymptote of the next one, go over, and we go down to our amplitude. Again, sorry that this line right here is not straight, it should be. So that will be the graph. So if you think full cycle, this would be 90, this would be 180, 270. So if you think about it, like it would have an asymptote here, so 0 to 180, it would cover the whole thing for the period of 180.